In this problem, we're told as you walk to class with a constant speed of 1.75 meters per second, you are moving in a direction that is 18 degrees north of east. How much time does it take for you to change your position by A, 20 meters east, or B, 30 meters north? Right, so the first thing you always want to do is draw what's going on. So we have the directions north, east, south, west, right? And so the student is going to be walking to class, right, at 1.75 meters per second, 18 degrees, right, north of east, right? So we go up 18 degrees north of the east direction, right? So that's what we've got going on. And so what we're trying to do is find how long it's going to take us to go 20 meters east and then 30 meters north, right? So what we're trying to do is solve for time, right? And the way we're going to do it is we know distance is equal to velocity times time, right? So if we know the distance we're trying to travel, in this case, it's 20 meters east, 30 meters north, right? We're going to do them separately. And then we can find the velocity that we're traveling in that direction. We can solve for the time, right? Because if we divide by v, what we can do is solve for the time that it would take. So the time is just going to be equal to the distance divided by the velocity in that direction, right? So what we want to do is basically write it in two ways. So we're going to do it for the east direction, right? This will be east. And then we also want to do it for the north direction. Okay, so it's basically the x and the y. But for the east, right, the time is going to be equal to the distance. What's the distance we're traveling in the east direction? So keep in mind this is east, right, 20 meters. And then we're dividing by the velocity in the x direction, which we don't know yet, but we're going to solve for it, right? And then for this one, t is going to be equal to how far we're moving north, right, which is going to be 30 meters, divided by the velocity in the y direction, right, because this time we're going up. So velocity in the y. So now what we want to do is find the velocity in the x and the y. So how do we do that? So the way you want to do it is just draw a triangle with your velocity at an angle, right? So draw a triangle. And so this is going to be our triangle, right? And we know the velocity, right? Whatever your velocity is, the vector, you just want to label it here. So 1.75, and then you want to label the angle they're going at. So in this case, it's 18 degrees. And so the way you're going to solve it, right? So I'm going to label this x, or sorry, label this y and label this x. And so what we do is x in this triangle, if we solve for it, it's going to be equal to the velocity in the x direction. And then the y is going to be the velocity in the y direction, right? So what we want to do is solve for it. So let's just start with x. So the velocity in the x. So basically what we do is use cosine. So the cosine of an angle, in this case 18 degrees, what is cosine equal to? So cosine is adjacent over hypotenuse. In this case, the adjacent x, which is what we're solving for, right? We want to find the velocity in the x, which is this variable. So it's equal to x over the hypotenuse, 1.75. So if you multiply both sides by 1.75, right, to get rid of that, you'll basically get x. And so x is just the velocity in the x direction. And so now we have it, right? So t is just going to be equal to 20 divided by v sub x, right, which is 1.75 times the cosine of 18. And so I'll solve this in a second, but let's do the velocity in the y now. So just like the last one, what we're going to do is just solve for the y instead this time. So, but this one we use sine, right? Because the sine of an angle, we know sine, right? So katoa, so the opposite over the hypotenuse. The opposite in this case is the y, and you want to divide by the hypotenuse, which is 1.75. If you multiply both sides by 1.75, you'll get y, and this is the velocity in the y direction, right? Because we use the velocity as the hypotenuse. So basically, it's going to be t equals 30, right? The distance divided by our velocity. 1.75 times the sine of 18, right? So sine of 18. And so now that we've got them both, right, all we have to do is just solve. So let's just start with the x. So 20 divided by 1.75 times the cosine of 18. And when you do this, what you're going to get is that it equals 12.016. So I'm just going to round to 12. So it's going to be about 12, and then this is time, right? So 12 seconds, right? That's how long it's going to take for us to travel 20 meters, right, east. So this is your answer to A, right? And now let's do the y direction. So 30 divided by 1.75 times the sine of 18. And so when you do this, you're going to get 55.475 and so on. You can just round, right? So we'll just say 55.5, or you can say, yeah, just 55.5, or you can just round to 55, right? So it's going to be about 55 seconds. Just make sure you round how your teacher wants you to, but it's going to be about 55 seconds. That's going to be how long it takes it to travel 30 meters, right? So this was your answer to A. This is going to be your answer to B. But yeah, so these are your answers, and hopefully you found this useful.